Hey everybody, lesson 11-2. Very little geometry actually involved in this lesson, and it's going to be very, very brief. Let's just read across the top of the page here. For this lesson, the value of x is not known exactly. Okay, we're going to just assume that x has some value, some very particular value. We don't know exactly what it is, but we do know that it is approximately 1.357. In other words, it has more decimal digits than that even, but we've just kind of rounded them off or thrown them away. And we know that these first three decimal digits are accurate, okay? But there's more digits that we've thrown away or we just don't know what they are. So in this first question, what is the value of 5x to the nearest tenth? Well, we would just multiply this value of x by 5, right? We'd get 6 point something, something, something. We round it to the nearest tenth. We'd get a result of 6.8. Okay? When I do this in class, nobody gets that problem wrong. This is the one that suddenly people start getting wrong and confused over. What is the value of 10x plus 2x exactly? And a very common mistake is for people to replace the x in those expressions with the 1.357, calculate some result, write down a number, and be pretty happy with that. But recognize, we've said here, we don't know what x is exactly. This is not the exact value of x. And I'm asking for the exact value of this expression. So if you replace the x in this expression with something that is inexact, you do not get an exact answer. Okay? At which point you might be thinking, so cannot be determined? No answer to this question? Well, that would be incorrect also. The value of 10x plus 2x is 12x exactly. Okay, this was not a trick question, okay? And I know you understand now that I've given you the answer, why the answer is what it is. 10x plus 2x has always been 12x, okay? But the point here is that if you replace a variable with a value that is inexact, that is only approximate, then you do not get an exact answer, okay? And that's the lesson you've got to learn today. I mean, that's it. We're just going to do a few more examples here, and this may seem like a really incredibly simple lesson, but it's very important to the work we're going to be doing starting in the next lesson and throughout this whole Unit 11, okay? So it's very important that you get this and you don't forget this as you're working through these problems. So what is 10x plus 2x to the nearest tenth? Okay, now we can replace the x's with 1.357. When we do all the calculations and round to the nearest tenth, we'll get 16.3. Nearest tenth is one decimal place, of course, right? And I expect you know how to round. That should not be a problem. What is the value of 5x times 4 exactly? Well, just do the algebra. 20x. Do not replace the x with that decimal. Again, this may seem really easy, but I am going to have to keep saying this sort of thing. I know from experience, I'm going to have to keep telling students, stop replacing this exact symbol, x. I mean, x is just x. We know what x is. It is x. And stop replacing an exact symbol with something that is inexact when I ask for an exact answer. I'm going to have to keep telling this to people. I know it. All right. All right, let's apply this idea to some unbelievably simple geometry here. Got a diagram here. It says for, questions 5 and 6, the value of x is still not known exactly. Still, it is approximately 1.357. So find the length of QM exactly. Well, here's Q, here's M. The length of that segment would be this 2 plus that 9, 11. Okay. What about the length of AC? That would be from A to C. Well, that would be that 9 plus that 3x. If I want an exact answer, you better not replace the x with this approximate decimal. Just write 9 plus 3x. That's it. That's as exact as we can be. Okay. The homework, very brief. You're going to love how short and simple it is. But this is, like I said, very important idea to get and not forget for the coming lessons. Right? We'll see you later.